Welcome to the 445th Airlift Wing. The primary missions of the 445th Airlift Wing include transporting personnel and equipment and providing aeromedical evacuation. We are located at Wright-Patterson Air Force Base, Ohio, and fall under the Air Reserve Command. Many of our missions support Air Mobility Command. With 9 C-17 Globemaster III aircraft, we are capable of delivering troops all over the world and all types of cargo to main operating bases or directly to forward bases in the deployment area. We transport food to countries like Haiti and the Ukraine. We deliver supplies and equipment to cities around the nation during natural disasters. Let's take a look at one of our C-17s now.
Hello, I'm Major Aaron Port, an instructor pilot with the 89th Airlift Squadron.
I'm Tech Sergeant Trevor Dixon. I'm a mission loadmaster here with the 89th Airlift Squadron.
We're here today to give you a tour of this C-17 Globemaster III from the 445th Airlift Wing at Wright-Patterson Air Force Base, Ohio. If you'll come with me, we'll start to take a tour of the outside. As you can see, the C-17 is a large aircraft. It's a 170-foot wingspan, 170-foot long, and 55 feet tall at the tail. Our maximum takeoff and landing weight is 585,000 pounds. We can carry over 150,000 pounds of mixed pallets, cargo, and passengers. So as you can see, the C-17 is powered by 4 Pratt & Whitney high bypass turbofans, each producing 40,400 pounds of thrust at sea level. Another notable feature of the C-17 is the high wing. Unlike airliners that have their wings and engines low to the ground, the C-17 has our engines elevated as high as possible so that if we're going into an austere location or a dirt runway, we have a smaller chance of sucking up any debris into the engines. You'll also notice the C-17 has winglets at the end of the wings. That's a key identifying feature for the C-17. If you see a big gray plane flying around, it doesn't have winglets, it's a C-5. If it has winglets, that's a C-17. Behind me, you'll see the main landing gear underneath the aircraft there. We have a rather unique configuration of wheels. It's called triple tandem. So on each side, there are 2 sets of 3 landing gear in front of each other. When we retract the landing gear, in order to save space, they actually come up and rotate 90 degrees to fit within the fuselage. Behind that, you can see the ramp extended down onto the ground there. You can see there's really not a whole lot of ground clearance under the aircraft itself. It's designed to sit low to the ground to make loading easier. So we have the ramp down there and what are called ramp tows, which Sergeant Dixon will tell you more about. That'll allow us to easily drive vehicles and equipment onto the aircraft. We can't see it very well, but as you look up, there's a ramp that ends about halfway up the opening there. The cargo door will actually go up while the ramp comes down, giving us a larger opening to load even larger cargo onto the aircraft. Now that I've given you some idea of what the exterior features and design of the C-17 are, we'll continue our tour and head inside.
All right, welcome aboard the C-17. Right here is the cargo compartment of the aircraft. As we sit right now, we're configured for loading vehicles, trailers, anything on wheels. If it can fit in there, we can ship it. We can get 8 Humvees in here. We can get 3 Blackhawks. We can get a Chinook helicopter in here if we take the blades off. RVs, the presidential motorcade. If it fits, it ships. So we've got 295 tie-down rings on the cargo compartment floor that stretch from the end of the ramp all the way to the front of the cargo compartment. So a vehicle will roll on, we'll spot it into position, and then we can flip these tie-down rings up, take this chain to the vehicle. That way we ensure that the vehicle is not going to move at all during takeoff, landing, or potentially an emergency situation. Now, we don't get to fly the aircraft as loadmasters, but our job is equally as important. If we don't do our job right, the aircraft never gets off the ground. We also can change to pallet shipping, 108-inch by 88-inch pallets. And we can do that. We have a rail system that runs, again, the length of the floor, and each of these rail systems has a locking system in here that we can control hydraulically, and that'll lock into the indents of the pallet, again, keeping anything from moving forward and aft. And we roll those on. With these roller systems, again, into the cargo compartment all the way up to the front. A good crew can reconfigure the jet in about 10 minutes from a completely slick floor to hauling 11 pallets down the center or 18 pallets with our logistics system. So now we take the pallets, we'll rotate them in the other direction, and they can fit with the same locking system as the ADS system right here. And once we're done, we've offloaded all of our cargo. The rails go down just like this. And we're ready for more cargo. And as a military aircraft, we fly with a lot of passengers, whether that be soldiers, fellow military members, or their dependents, even children sometimes, retirees, people on leave going space A to Hawaii sometimes. We do that. We have 54 sidewall seats that flick down just like this, all the way 27 on this side, 27 on this side. And then what you can't see behind you is up on the door, we actually have more centerline seats that can go down the middle of the aircraft. They lock into the floor, and we can actually fit up to 102 people. Now, our seats also will accommodate Army paratroopers, fully decked out in all their gear. They can sit here with their rucksacks, their parachutes, whatever they have to leave the aircraft in, and just try to make it a little more comfortable. But as you see, you can see a lot of the interior of the jet. Now, we're not like a commercial airline where everything's nice and quiet in here. It's pretty noisy. You have to yell at each other sometimes if you're not on headset. But yeah, this is how we handle our passengers. Each passenger has a life jacket. They've got an oxygen system, just like on commercial aircraft, that'll come out if we lose pressure. And then underneath the seat is our emergency passenger oxygen system, which is basically a plastic bag that'll go over your head with an oxygen cylinder on it in case we have any smoke or fumes in the aircraft and we have to run our emergency procedures. We want to make sure all our passengers are taken care of, just like the rest of our cargo, because they're a lot more important, and we want to make sure that they get to where they need to go. Right up here we have our wing box. So this is actually an extended range jet. You can tell by the three straps going across the wing box. And that's where our fuel sits. We have 4 fuel cells, and as we sit right now, the aircraft is capable of handling roughly 245,000 pounds of fuel. And inside the cargo compartment, we can carry 170,900 pounds of cargo. So it makes for a very heavy jet if we have to load up, if we're doing a long range mission somewhere. The longest I've flown was 11 hours, and that was from Afghanistan to Diego Garcia without aerial refueling, which we are capable of in this aircraft. You see on the sidewalls here, just like back there, we have our devices placed throughout. That way we're not having to run back and forth trying to tie things down. We've got 10,000 pound devices right here. We've got our tie down straps for our smaller cargo, cardboard boxes, stuff like that. We've got along the side, we've got our walk around bottles. And if we have to run any emergencies and I have to leave that seat up there, we want to make sure that we're on oxygen so we can take care of all our passengers and extinguish any emergencies that might come to pass. As you see, we have our first aid kits on our sidewalls right here. We've got our fire extinguishers down here. Up here is our captain likes to activate these when he wants to tell people to sit down and buckle up if we're hitting any turbulence or anything like that, or even if we're on descent into our next station. We'll move on up. Let's go. Kind of talk about our litter stations, and then move into the forward Loadmaster station. I can show the winch if you want me to, and kind of the galley area. All right. Also on board, we are capable of turning the jet into essentially a flying hospital. We have our litter stations right here that our aeromedical folks can take off the wall. They can lock into the floor down here, and we can take full ambulatory medical patients. We can bring them back from overseas, from downrange. We can make sure they get, say, to Ramstein or something like that, to a good hospital so they can get the care that they need. Fully capable. We have oxygen system for them, therapeutic oxygen. So if someone needs, oxygen that they're breathing on, they can get that. We have a separate oxygen system for our passengers, and we also have an oxygen system for our crew, and then we have an auxiliary oxygen system. And those all kind of tie into each other to make sure that everyone has enough oxygen for our duration of the flight. They have their little stanchions right here. They can call their attendants, and they can turn their reading light on, whatever they need to do. And up here we've got more oxygen bottles. We've got our snatch blocks. We have 4 snatch blocks because we actually, under the floor right here, we have a cargo winch. And this winch can run out past the length of the cargo compartment. We can hook up to a heavy vehicle or a helicopter that may not be able to move itself on board. We can pull this on board, we can move it to wherever we need to go, and make sure it gets tied down appropriately. Right next to our winch, we have our lavatory. This is well, it is what it is. On those long, multiple-hour flights, it's important for us to make sure that we have, proper facilities, as they say. And right here is our galley. We have a fridge, we have an oven. So again, if we're flying those long distances, we want to make sure that our crew is able to eat and stay hydrated. We also have igloos over here, 5 gallons of fresh water. I want to make sure everybody's able to fly, fight, and win, is what they say. And then on up here is our flight deck. And then this is my office right here. This is the forward Loadmaster station. From up here, I can control everything from lights. I can monitor all of our lock systems that we have our pallets locked into. I can check our oxygen systems. I can use the radios. I can talk back and forth with the pilots. I can also call forward ahead to the next base, talk to their command post, let them know how much fuel we need when we land, how many passengers we have to offload, how much cargo we have to offload, and I can also get an idea from them of what we're going to be taking out of there. So this is where we also calculate our weight and balance for the entire aircraft. We want to find the center of gravity of the aircraft to make sure that we're flying as straight and level as we can. So once we get all of our cargo in here, we'll punch our numbers in, and if we need to adjust anything so that the aircraft can fly level and happy, we'll do that before we take off. That computer talks to the computer upstairs where the pilots are. They type in their numbers, and the jet will more or less figure out how it needs to pitch up or down depending on how heavy we are downstairs. And under here we have just some storage drawers. So we've got additional communications cables. We've got a couple of toolkits. We have the rail roller system that I can get out and I can put these rails up and down with. We've got our own oxygen system. If we have to go on oxygen for any reason during the flight, I'm able to do that with my headset still on, and I can talk to the pilots so we can run our checklist and mitigate the hazard as we need to. And then on upstairs is our flight deck, our crew rest area. We have 2 bunks on board. We have a pilot bunk and a Loadmaster bunk. So we want to make sure that everyone's getting a good work rest cycle. We don't want anybody flying tired. Usually our overseas missions are 7, 8, 9 hours. We want to make sure our pilots are fully 100% alert, oriented, awake. And also for our Loadmasters, we want to make sure that we're well rested so that when we get to our next duty station, we can offload all of our cargo accordingly. All right, so here at the forward cargo compartment load station, we've got our little desk right here. We can set out all of our paperwork, our passenger manifest, cargo manifest, anything that we need. We can fill out our customs forms if we're coming back from overseas. Like I said, we can control all of our lights from here. We can monitor the status of our locking systems. We can do our life raft ejection sequence from right here. Up above you, there's 2 life rafts and there's one in the back. 46-man life rafts that'll actually punch a hole through the skin of the aircraft if we go down in water, and they'll eject 46-man life rafts out into the water. And we can monitor all that from right here. We've got a smoke detection system for all of our smoke detectors on board. Various circuit breakers for our cargo compartment. And yeah, that pretty much wraps up my Loadmaster station. Let's send it back to Major Port upstairs.
And welcome to the flight deck of the C-17. Unlike many older aircraft, the C-17 only requires a crew of 2 pilots, the pilot and the co-pilot, to fly the aircraft. There's enough computer assistance that we don't need a navigator or a flight engineer. What that does mean is a lot more workload for us sometimes, but we have a lot of training to help us get through it. The C-17 is the most modern mobility aircraft employed by AMC. We have fly-by-wire flight controls and heads-up displays that allow us to perform our mission even in bad weather. We are night vision capable. We can ingress at low altitude down to 300 feet AGL, or perform a high altitude ingress at altitudes up to 42,000 feet. Max airspeed for the C-17 is 350 knots. Usually we cruise around 310 knots at 35,000 feet. It's very similar to where commercial airliners fly. We have 4 turbofan engines producing 400,000 pounds of thrust each, for a total of 160,000 pounds of thrust. Max aircraft weight for the C-17 for takeoff and landing is 585,000 pounds. We can land on assault strips that are unpaved with dirt down to only 3,500 feet long, and then take off again. We're designed to handle an M1 Abrams main battle tank, or 18 pallets of cargo, and any number of other outsized cargo that might be required. I'm an instructor pilot here at the 445th Airlift Wing. That means that I'm in charge of both taking new pilots direct from pilot training and letting them work their way up from a co-pilot to an aircraft commander and eventually to upgrade to instructor as well as teaching any pilots that have lapsed in their currency due to maybe medical issues or civilian commitments. It's our job to bring them back up to speed and make sure that they're fully mission qualified. We fly for the Air Force Reserve Command as they need to move troops and supplies around the United States in support of exercises and training, as well as flying real-world missions for Air Mobility Command across the globe. We have regularly scheduled missions that bring us to Europe, the Middle East, and the Pacific. And then we also fly on-demand missions to AMC basically anywhere in the world. We fly with or without aerial refueling. Usually our range is about an 8 to 9 hour flight unrefueled. That will easily get us across the United States or the Atlantic Ocean, or about halfway across the Pacific, say California to Hawaii, without needing refueling. With refueling, our range is basically unlimited. As I said before, our basic crew is only 2 pilots. However, if we have a long day, we bring at least 1 extra pilot and Loadmaster with us so that while 2 pilots are flying, we can have a 3rd pilot resting, and that lets us fly for as long as a 24-hour day with 3 pilots. And now let's go ahead and take a look at some of the instruments that let us fly. So this seat is the pilot seat on the left-hand side. Can be flown from either seat. Controls are basically identical, but we'll start out here. This is the stick. Like I said, it is a fly-by-wire stick, but it's got very much traditional feel to move forward, backward, left, and right. The other primary controls, the throttles here. 4 throttles, 1 for each engine. We also have controls for the flaps and a couple other flight control issues right in the center. Along the front of the glare shield, we have a lot of different configurable displays, known as multifunction displays, because we can choose what information to display based on the needs of the moment. Along the center console here, we have what we call mission computers. They let us tell the aircraft where and how we're planning on flying so that it can do the math and calculations behind the scenes to tell us things like how much fuel we're going to burn for a flight, how long it will take us to get to a certain point, and what speeds we need to take off and land at a certain airfield. We have additional controls to control what we display on the maps and such. We also have controls for our defensive systems, for opening the doors, and a couple miscellaneous controls. Above the glare shield, we have heads-up displays for the pilot and the co-pilot. Those give us the ability to look outside the aircraft but still monitor our instrumentation, the flight path, speed, altitude. They give us a lot better situational awareness, especially when we're doing tactical operations, low-level flying, or in bad weather conditions. Our communication panels sit up front as well. They allow us to easily control the 7 different radios that we have access to. In the center of the glare shield is the auto flight control panel, or the autopilot. That's where we can select our altitudes, airspeeds, headings, etc., so that our autopilot can help us maintain our flight plan with excellent accuracy. The autopilot allows us to fly for long periods of time without the associated fatigue of hand flying. It also does an excellent job of maintaining courses and altitudes better than even the most proficient pilots can. Up above on the overhead panel, there are a lot of additional controls for various systems across the aircraft. Flight controls, the electrical system, the fuel system. It also has our central warning and annunciation panel. It can tell us any errors that go on with the aircraft. It will tell us what it is, so we can reference this panel and then go into our checklist and correct any problems that might arise during the flight. It looks very complicated, but I promise we all know what all the buttons do. Along the glare shield here, we have a total of 4 multifunction displays. These let us display different data depending on our needs during the flight. Here I have our main navigation display. It will display our current location, our flight plan, radar or terrain as necessary, nearby airports or navigational aids, so that we can have good situational awareness on what's going around around the aircraft. This display here is currently showing our primary flight display. This is a combination of a lot of traditional instruments that allows us to look in one place and get an excellent understanding of what the aircraft is doing. Along this side, we have our airspeed in knots, indicated airspeed. We have the altitude above sea level, and we have our current compass heading. The large central area is called an attitude directional indicator. So that tells us what our pitch is, nose up. So as you start pulling the nose up, 5 degrees, 10 degrees nose high. It will also tell us how much bank we're in as you start rolling left or to the right, and helps us to maintain controlled level flight even if we can't see the horizon or the ground outside because it's either night or we're flying through clouds. Further along, we have several pages of engine instrumentation telling us things like how fast the engines are turning, how hot the exhaust is, fuel pressure, temperatures, and so forth. This is the crew rest area, where on long missions we can have up to 2 crew members sleeping and allowing us to extend our duty day so that we can fly across the oceans and make it to destinations further away than if we had to stop and spend the night. So we have 2 bunks here, and then additionally there are 2 other seats for crew members that might be required, or if we're bringing additional ground personnel like crew chiefs to help us when we get to our destinations. This is also where the stairs come up onto the flight deck, so it can be a little noisy, but it's definitely better than sleeping in the back.
A C-17 can be configured into a flying hospital to transport patients from the battlefield or disaster area to a medical treatment center. The Air Reserve component, consisting of the Air National Guard and the Air Force Reserve, comprises approximately 87% of the total aeromedical evacuation for a structure. AE personnel play a critical role in medical evacuation during both peace and conflict. A C-17 Globemaster III is capable of carrying 36 litters, 54 ambulatory patients, attendants, and medical personnel.
Hello, good morning. I'm Captain Nate Copen, and this is Master Sergeant Brenna Pagoy. And we are part of the Aeromedical Evacuation Squadron here at Wright-Patterson Air Force Base, Ohio. Today we're going to be discussing our capabilities on the C-17. So for AirEvac, this aircraft was definitely designed for us. We're pretty fortunate with all the equipment and its capabilities. So as you can see here, we have our typical setup. This aircraft comes standard with 3 stanchion setups such as this. We have this set up as our emergency get-down litter with our mannequin patient and then our emergency equipment litter. What makes the aircraft unique for us is that it has its own electrical system on household power. So with that is 60 hertz for 30 amps total for our aircraft, and then we have 400 hertz system with 20 amps on each side of the aircraft, giving us a total of 70 amps per each mission. We also have therapeutic oxygen, which is nice for our patients. We usually use the MPT locks on most aircrafts, but with this one, it already comes standard with two 75-liter locks oxygen tanks. So that's also very convenient for patient movement and setup. We also, with this, we have our tower set up here. So this is actually just like a hospital. You have your call light system, and then you also have the light. So, and then each one of these, like a commercial airline, has the Dixie cups. And with those, if an emergency would occur, they would come out for our patients. So as you can see, it's become very simplified for aeromedical evacuation to come on and set up and head out for a mission. Additional features for the aircraft would be the LSAS, which provides us an additional 9 of these stanchion setups, which gives us 12 total for the aircraft, and that would give us the opportunity to move 36 litter patients. As a flight nurse, we have one of 2 roles on the aircraft, either as MCD, which is our mission crew director, or your flight nurse, second flight nurse as we call it. Both roles are both flight nurses. One just has more charge of the mission. The other one is providing patient care and delegating patient care to one of our 3 med techs. With that, we conduct a brief before every mission, and we plan our configuration for this aircraft based on what we see as far as patient load goes. And once coming out to the aircraft, as you can see, we have plenty of room to do what we got to do. A big thing that we look at when we step on this aircraft, everything's for safety. So we always look to the back of the aircraft or the aft to make sure that our 2 ramp toes in the center are up and that the outer ramp toes are stowed away. This way, if we had to emergently egress the aircraft, we'd have the ability to go off the sides of the ramp. So, one of the other capabilities of this aircraft that is nice for us, especially in contingency situations, whether it be HURAVAC or downrange somewhere, is that we have the ability to floor load 48 patients on the main floor here of the cargo compartment, as well as 12 additional patients on the ramp, which would give us 60 total patients being floor loaded at a flight level no greater than 350.
All right, so with the 8 aeromedical evacuation technicians that we have on the plane, typically we fly with 3, and one of them would be the charge med tech. We can have capabilities up to 5 med techs on the aircraft, depending on patient load or how long that we're flying. With the charge med tech, there's just additional duties with assigning who puts up the oxygen lines, who puts up the electrical, and then when we come out and do setup, they're in charge of that, making sure that we do things on time, and that if somebody needs something else to do, that they can assign that for them. They're in charge of the whole setup, making sure that things are done correctly as well, and being a safety monitor as well. With our additional capabilities, we can fly with cargo so that the front end can do some of their mission as well, along with patients. It just depends on what cargo we're bringing along, and it changes up the setup when it comes to that. Yeah, for the charge med tech, the first thing that we do when we come out to the plane is talk to the Loadmaster to see if there's anything that's wrong with the plane, if we have anything that we cannot do. Say we're refueling, we can't plug into our oxygen or electrical until that is complete. So it's a big thing to make sure that that's ready for us to do. We also coordinate with them with the weight of the equipment that we're bringing on, as it may or may not affect their load plan. They're pretty in charge of what was on what part of the aircraft. So we make that coordination with them at that time. We also coordinate with them for the ground people that we have, the ones that are bringing out the patients. Our own equipment, they're ones that we coordinate with, along with the Loadmaster, to make sure that things are backing up to the aircraft correctly. We collaborate with our flight nurses to make sure that we have a patient care plan. We're all EMT certified, so we do take care of patients on this aircraft. It just depends on what is assigned to us by that flight nurse. And then the charge med tech coordinates with the MCD. It's like a funnel. We get all the information from the rest of our crew, and then get it to the MCD so they can make their decisions. And then we get that decision and funnel it back out. So it's like it is maintaining that closed loop communication.
Gives us the ability, if we have to shock a patient, cardiac arrest, we have that ability. We can do synchronized cardioversions with this equipment. as well as pacing. So this is like our number one in any emergency situation. This is what we're going to utilize. And then we have like its smaller version, the M, which is just your basic monitor with not all the capabilities of this. So we can also do a 12-lead EKG with this as well. So it's almost like we're set up like a hospital, but our equipment's more for like first responders in a sense. Now again, we also have our IV pumps, the bronze. These are brand new actually. We just got these. I do like them. They work really well. We can stack them into 3 here, but we can use each one individually. And that allows us to give IV fluids that we don't want to, if we run them by gravity, obviously we don't need it, but if we just want to run these, like if we have a pediatric patient, antibiotics and such, we got to use a pump, so that's why we have that. So this is your standard setup, your blood pressure, your leads for your EKGs, and then your pulse oximeter to get the oxygen saturation on the patient. Before we take off on any mission, we get a baseline set of vitals on the ground. Typically we can do that, we can accomplish that with this, or if we have a bigger patient load or we just don't have much time on the ground, we use what's called a known-in. It's just a much quicker way to get oxygen saturation and a heart rate. So as you can see there, it's green, so we know it's good to go. We're getting our numbers, and then we're able to press on from patient to patient.
The big thing with this equipment is it is approved for flight, so it goes through a pretty rigorous process, and once we get that, it can usually happen for a good couple year or two before they switch out. The main thing that would switch out would be if there's any additional defects found with it, but the Zoll we've used for quite a bit, and the main difference between the MD and the M is, again, it doesn't shock, basically. You can't use it for cardioverting. However, the one way you can tell the difference is there's no big red right there, so you make sure you grab the right one. They look pretty similar.
All of our equipment goes through a pre-flight. Before we step to the aircraft, we do a full pre-flight per our checklist. And then once we come out to the aircraft, we have to make sure it's safe on the aircraft and that it's still working on aircraft power. As I mentioned before, we have the 60 hertz household power. We plug into that, as you can see. Once we've plugged in, once we got the okay from the Loadmaster to plug in, we would plug in and we would see it light up, and then we would run our function check checklist. That would then let us know that everything's still running appropriately on aircraft power. So it goes through two different checklists before we even fly off, before we even take off. So we definitely are very thorough with our equipment before we fly.
When we do have mannequins that we bring out for simulated training, we can either use the mannequins or a live person who is in that role for pretty much the entire flight. The one thing that you do want to double check when you have them is, like, we do the hang IV bags. If there's a Foley catheter, we hang the bag below. We want to make sure we take care of these people, these mannequins or simulated patients like they were real.
So when we train on the aircraft, we want to train like we would out in the operational area. So the load here is going to simulate what it looks like in the aircraft when we do an operational mission with real patients. As you can see, it's fairly dark, so we have to adjust to this environment when we're flying downrange, or we have those long flights across the Atlantic from Ramstein to Andrews Air Force Base. So what you're seeing here is exactly what a nurse would see or a med tech taking care of a patient. Low light, so a lot of us will wear a headlamp on this aircraft, or we use like a low dim flashlight. That way we're not, putting a bright light on our patient. And as you can see, our equipment, you can't hear on the aircraft because it's loud, so we're all usually on a headset communicating on this aircraft, but we also rely on the visuals. We can't hear the alarms going off, we rely on the visual. So it does take a few seconds to get acclimated when we do go to this low light setting. But as you can see though, it does work, and that's one of the other nice things about this aircraft is the lighting system. We can go red or green depending on the scenario for that. A lot of the other aircraft we fly on does not have this lighting capability like we have here. So this provides you some insight on what it really looks like when we're flying a real mission. The other aircraft that I know of that has a household plug-in is the C-130J model. So that is one of the nice features. As you can see, we could just plug in. If it wasn't for this, we have what's called a Unitron, and we'd have to connect that in order to plug in this into that Unitron system. And then the oxygen, as we discussed, the therapeutic oxygen, that's huge. We can have up to 150 liters of LOX on this aircraft, which is a lot.
We hope you enjoyed the tour of the C-17 Globemaster III and a glimpse into what we do here at the 445th Airlift Wing. Aim high, fly, fight, win.